Hello, good morning. My name is Mohammad Rafi. I'm a student of Leeds Package University, MS Cybersecurity, and my student ID is C7546350. Today, I present you my research topic that is machine learning-based phishing website detection. So let's move to the agenda. So this is my agenda. First of all, I give you an introduction of my topic, then research gap, and then I will share a problem statement with you, research objective. I share a proposed methodology and result of the dash methodology, and finally I move to a demo. Uh, Phishing websites are the fraudulent site designed to trick user into a relevant sensitive information such as username, password, and financial detail, bank account, etc. They often replicate trust organizations like bank, e-commerce platform, or government portal to appear legitimate. Phishing has become one of the most uh, worldwide and demanding form of cybercrime, causing sufficient financial and data loss globally. Attackers are smart. Attackers continuously involve their technique using zero-day tolerance redirection tactics that make detection increasingly difficult. Traditional blacklist and rule-based systems struggle to keep pace with these evolving threats. The growing challenge has made phishing website detection a critical area of research in cybersecurity. Let me show you the type of the phishing websites that are used in fraudulent HTTPS phishing, website pooling, search engine phishing, clone phishing, pop-up phishing, social media phishing. I will share example of this type. HTTPS phishing, fake website with valid SSL certificates. This is example of HTTPS phishing. Website cloning. We can clone a legitimate website and with some fake detail on it, and we'll share a link with the user to use that one. This is the example of this is the definition of clone websites. So let's move to the research gap. In existing system, there is a limited feature diversity. So I use a data set in which I have a 55 features. So that is in that the missings the advanced features of website like JavaScript, CORS, and CRSF tokens. So these are the feature advanced that is missing the existing data set. Um, a large number of high-perform machine learning and deep learning model are black box, often little transparency into a way a website is classified as a phishing, which reduce trust and adopt in real-world security system. So in existing system, currently model often fail to detect zero-day phishing attack. So attacker basically bypass the rule-based or static detection system, a rule-based system. So attacker basically bypass the rule-based system. So this is the weakness of existing system. Real-time application gap. Most existing studies focus on offline dataset experiment with limited work done on deploying model into a real-time environment. So imbalanced data set. So I have a data set two classes like legitimate and phishing site. So the data between these two are there is a not properly balanced data on between these two classes. So this is the existing gap of existing system. So my problem statement involves around In traditional rule-based and blacklist detection method are efficient against zero-day phishing website and leave user exposed. Uh, Limited in existing data set, I have featured on only related to websites that like we have a not security related features involved on it, not HTML and JavaScript advanced features are present on that one. So I use uh, uh, the method that is explain which feature is more relevant and which feature is not relevant according to our problems, our topics. Like it's a this feature is rated have a phishing or not. So I use explain these features. So the research objectives are so I will extend the existing system uh, and add some diverse features and advanced security rated feature on it. Compare between the machine learning model and deep learning model. So I will compare the evaluation matrix of these two method, and I will also use shape to explain the features and transparency of the data sets. So this is my research methodologies. First of all, I will collect that data and extend the existing data using automated script that written in Python. I will process on that data set and clean and scale that data set. Then will I deploy two different techniques like machine learning models and hybrid deep learning model. In machine learning model, I use random forest and decision tree. I also use shape to explain the importance of the features that is related to a target class, that is the website is phishing or legitimate. Then I will train a model, both types of model, machine learning based and hybrid model, and then I will show the evaluation metrics of these models. Uh, In existing data set, I have almost 2,35,795 website record, in which 1,34,850 are legitimate and 1,945 are phishing website. So as I told you earlier, I will extend existing data set. First, I have a existing data set have 55 features. Now I will extend to a 83 features. So in this extension, I will use security headers, JavaScript behavior, and HTML attributes. So feature is extraction using the automated script and parsing techniques. I used the tool like Selenium, Beautiful Soap, and WebDriver to extract these advanced features from websites. So data processing, I will clear and prepare this data set that is used in model training. So let's move to the model development part. So machine learning model, in machine learning model, that is the most common flow that is used. I use, so first of all, I will clean and encode a data. I will check if data set have any missing value and any redundant data and have a categorical column convert into a numerical form, that is basically encode string into a numerical form. So feature selection and reduction, there's a lot of features. So I remove the redundant high correlated features to improve the efficiency of a model. So I use Smart to balance the classes legitimate and phishing website. So I use the Smart technique to balancing a data. Then I will split a data into training, testing, and validation steps. Mostly 70-30, I use that ratio. 70% data is used for training and 30% data is used for uh, testing and validation purpose. In hybrid model, I will group up features of HTML, JavaScript-based features, security-based feature, and URL-based features. I basically uh, group into a three types: a URL-based feature, HTML, JavaScript-rated based feature, and security header-rated features. So in URLs features, it's a mostly string and string value. I can tokenize and normalize using LSTM. In HTML user, I use CNN and convert these feature into a vector form and use CNN layers on that features. So in security header rated feature, I encode in dense layers of the models. So then I will use splitting technique. That is, I split the data in training, testing, and validation purpose. It's the same like 70-30 ratio that is used in machine learning model. Then I will integrate, compile that model and convert into connect a fully connected layer that is used, that is give me a final result like this website is phishing or not. And I will also use shape to explain the feature importance according to our problems. So let's show a result. This is the machine learning model that is random for us, as shown that let me explain your confusion matrix. In confusion matrix, I use a testing data that is 35%, I think 25% because 20% because I convert a testing data into validation and testing. So 10% in validation and 20% is used for testing purpose. So in that, as you can see, that highly positive and true positive and true negative result is have a most number of values. Like if a website is phishing, the model gives you a phishing result. If a website is legitimate, the model gives you a legitimate result. Very few number of false positive and negative, that is the misclassification. If a website is phishing and model give you a legitimate site, and and vice versa. The evolution matrix, it shows that the model have 99.8% of accuracy and precision, and recall is 99.7%. In the above diagram that show a learning curve of the random forest model, that is the smooth, as show that there is no overfitting, this line never passed every point of the data set. It shows that they randomly um, draw. So this very smooth. There is no overfitting on it. Let's move to our decision tree. Uh, Same like above, in confusion matrix shows that the model is highly predict true result, but as compared to random forest, it give you a maximum, most number of the wrong output, like misclassification. Like if I push a phishing and model give a legitimate website, if I do a pass a legitimate website URL, model give me a phishing website. So in that model, the accuracy is 99.6% with strong precision and recall. In the above diagram, this is the learning curve of the decision tree that is the same as in the random forest. Let's move to the hybrid model. In hybrid model, confusion matrix is more powerful with compared to machine learning model. This shows that our features extraction technique that I use a sharp that is give me a good result as compared to machine learning model. In that, the accuracy is 99.9% with strong precision and recall, and learning curve shows that the model is perform optimal and give a true result. So let's move to our data analysis. I make some analysis on the data set I used. So as shown in that, the website has 134 number of 1,34,850 number of legitimate sites and 1,945 number of record is phishing websites. So this is the heat map of uh, features I used in our data set. So it shows that which feature is dependent upon the target class. So it's basically a relation between the all features with the target class data shows that the website is phishing or not. This is the result of HTML features that is mostly I have a lot of number of features, but this graph shows that which most uh, impactful feature in our data set according to this diagram shows that the meta refresh, these all the features name and show the which feature have a which features give me uh, like according to our target graph, which features have a most impactful. So this is the like number of records. So same like HTML, I also apply sharp on these security features. So this is the same graph, but the features is different. Or so let's move to a demo. My demo is consist of three part: data analysis part, model training part, and website part. Let's quickly go through that one. So this is the my hybrid. Let's move to the model training. This is the my hybrid model. As you can see, model I will install the library that is not available in Kaggle. This is file load data set give me a number of, this is the shape, this is the number of records, and this is the number of column. So as you can see, it's as I explained, I will group into a three parts. So this I will grouping all these feature into three parts. And this is the model architectures. After model architecture, I will compile this model that give me a summary of model according to layers, which layers have which things. So in that point, the training of the model is started. So I set the 10 number of epoch, which means that this model repeat 10 times to give a best result. Here I use shape method, and that is the graph of that I explain in my presentations. I'll show that before smart apply, I have this thing. After smart, as this, you can see, the number of classes is balanced. So this is the accuracy, precision, and recall that I showed, and this is the confusion matrix. Let's move to the machine learning model. So let's quickly move to the model training parts. This is the feature engineering. So here I use check which features have correlated to our target card using this heat map and remove that feature that is highly correlated. So I will remove the feature. I set the threshold like 0.7%. So more than 0.7%, I remove that value because we use the less correlated features. So here I can use standard scaling approach to scale the data set. And here I train a random forest model with some hyperparameters, and it's give me a result like this is the confusion metric of random forest, and this is the classification of the report of the random forest model and the learning curve. And quickly move to the second machine learning model, that is the decision tree. So confusion metric, classification report, and learning curve. Let's move to our data analysis part. So I show some graph to visualize the which features, comparison between the features and all these things into a Kaggle notebook. So here is the distribution of legitimate and phishing websites. Here shows that which features have phishing features, legitimate features, and has title have phishing feature, has description have phishing. So these four features I use to make this graph: title, description, icon, and responsiveness. Behavior patterns. So here you can just IP domain related features. So here you can see that legitimate sites have IP not involve IP. So mostly phishing websites have a IP address. So legitimate sites according to our data set. So here is the sample of graphs. So that's all. And let's move to our website. So first of all, I create account and log into my website. Before login, I cannot use any thing. This is the feature, so I can use this is not impacting. So let's log in. After login, it show me that the phishing website introduction and the contributors models result that I copied the graph from the notebook file and paste into here. Dataset features, as you can see here, which features involved in the legitimate site and which is not involved, in which features is involved in the phishing sites. So these are the extended features, not the existing feature. That is feature I extend using script. So here I can divide the all features uh, into a 8 group to batterly visualize. So all we make a group of 10 to compares this URL with the phishing target class. Let's quickly move to analytics. That is the same graph that I shown in the notebook file. Let's move to quickly move to uh, testing first. So this is, I think, a normal legitimate site. So when I use this one, so it shows that this website is legitimate website URL and the feature that extracted from that websites. Let one I pass the uh, phishing website URL, so you can check that. So as you can see, this is a phishing websites with these feature analysis. That's all for most sites. Thank you so much.